Hello everyone, thanks for joining. I'm Shraga from viTesters, and so far we have conducted a couple of webinars, and I believe we could go to that extent because of the interest and participation. So I'd like to thank you for that genuine interest. Without taking much time, let me introduce today's industry expert. He is Bas Dijkstra from the Netherlands. Welcome, Bas. Thanks for accepting our invitation. Bas is
Thank,
a test automation trainer and consultant, and I'd like to introduce him as a technical QA expert in our industry, in our field. And I think he has nearly over 2 decades of industry experience. And during this time, he has supported many individuals and organizations acquire automation skills. So even though today's topic doesn't belong to automation and it is all about API security testing, if you need any guidance for test automation, you can contact him. You can contact Bas. And yes, regarding today's topic, Bas will bring important points about API security testing. And as you all know, nowadays our industry is using AI-powered tools from the beginning to the end. And I know AI is a great assistant, but when you are using these tools by disclosing certain information, then you should know how you should take secure integration practices. Therefore, I believe this is not all about AI, but I believe this session will be a helpful one for you to get more insights about API security, AI integration, say there's impacts and so on. And at the end, you can ask questions if you questions and Bas is a nice and friendly person, so don't hesitate to ask your queries. Uh, yes, Bas, good to go. Thanks.
thank you so much for that wonderful introduction, Vishanka. So yeah, I have got also on my behalf, thank you so much for taking the time out of your day. I really appreciate it. I think you gave a wonderful introduction already. So without further ado, let me just start by um, helping you uh, get a feeling for. So what I want to talk about again, API security testing. Let me start by why is this important? Um, and this slide basically tells you why, or is an attempt to tell you why. These are numbers from 2022, so a couple of years ago. I don't think they've gone down. Um, but basically in 2022, 83% of all the internet traffic is API driven. That is a lot of data, and some of that data is public, but definitely a lot of that data is should not be accessible to just everybody. And hackers have been trying to get access to systems for decades now. But unlike code bases and databases and servers, APIs are out there in the open because they typically transfer data across uh, internet enabled protocols like HTTP, which makes them a very easy attack vector. As a result, there's been a lot of high profile because companies failed at properly securing their APIs, which means there are a lot of data leaks, data exposures almost every week, in some cases almost every day. And then, of course, there's all these regulations that companies have to conform to GDPR here in the EU. I think PCI is an American thing. I'm not entirely sure, but well, it doesn't really matter where you are. Your government will have rules around data protection, or at least I hope they do. Which means we as testers and as developers or people who build or help build software, we should concern ourselves with the security of our APIs, or rather the security of the data that is exposed through these APIs. So, Vishanka, as you already said, I've been in this field for about 2 decades now. I'm closing up until two of I'm closing up to 2 decades. And for a lot of that time I thought, oh, security testing. Yeah, I know it's important. I don't really understand it. Um, and I would like to leave that to the experts. It's something that you have to have deep technical, you have to have a lot of deep technical knowledge, a lot of highly specific tools. That is the general image, at least in my mind, and I know in a lot of other testers' minds as well. Uh, it is something that is best left to the experts. And to some extent, that is absolutely true. However, the nice thing with API security testing is that there's a lot you can do without that deep technical knowledge, without highly specific tools. There's a lot of API security testing you can already do with just a healthy dose of curiosity, creativity, and common sense, and just regular API testing tools. And that's why I created this talk and sort of kind of live testing session to show you that even with just asking the right questions and using common API testing tool, in this case, I'm going to use Postman, but that could really be any kind of tool. Um, there's a lot of valuable information about the security of your APIs that you can uncover. So yeah, basically this. And there's a lot you can do without that deep technical knowledge and those highly specific specialized tools. So I could tell you everything about different kinds of vulnerabilities, but I'd rather show them to you so you get a much better feeling of, well, what is it that we're talking about? What is it exactly that we're looking for? So that's what this session is going to be. I'm going to perform some testing on some APIs, some endpoints that I prepared myself, just to show you what to look for and to show you, well, how can I get started at a very low level, very easily, very straightforward. How can I get started thinking about API security testing and actually performing API security tests, again, without super specific knowledge or tools. Um, so there is my Postman instance. So I've got an endpoint here that creates a new user, a username banana. That's weird. Let's call them John. If this is an endpoint that creates a new user in some kind of system. So when I call call that endpoint, it generates a new user. All fine. If Susan, if I create another user, it creates another user with another user ID and the username. Excellent. Um, However, you've probably seen APIs, systems respond like this. So in this case, if I leave the username empty, or if I leave that username parameter out altogether, I'm getting some kind of null pointer exception. This in itself, this is a bug. This is not how my API is supposed to respond. But this is also a security issue. Exposing these implementation details, because that's what a stack trace does. It exposes details about the implementation, about the internals of your system. Um, this is then information that attackers can use to A, find more information about the implementation of your system, and B, maybe abuse that because they can say, oh, you're using Catalina as a web server. You're using Tomcat. There's all kinds of, this is all, and maybe even from this stack trace, they could deduce, oh, they're using a specific version of a web server or whatever kind of library or application or platform that you're using, which might give them, which might have some known security vulnerabilities that they could then expose. So why am I starting with this example? Because this is, to me, um, I want this to be seen not just as like a functional defect, and the fact that my application exposes details about the implementation to people who are not supposed to see this. But this kind of information is also very valuable to people with malicious intent, hackers, because they could use this to get more uh, info about implementation of systems, and maybe they could abuse that. And that's why I called this example exposing TMI, too much information. Um, every time, because I want to make people aware that every time I see a system expose implementation details about the code base, the programming language, the specific libraries that they use, the specific servers, the server versions that they're running on, that is all information that can potentially be abused by hackers. So from now on, please do me a favor, do everybody a favor. If you see your system exposing these kinds of implementation details to end users, signal that, oh, this is not just a functional problem. This also might this also might pose a security risk. Um, so again, exposing sensitive implementation details. Um, something that is very. Next one is next example that I've got is this one. Another a slightly different way of creating a new, in this case, a student in some kind of student administration system. This is typically one of the first kinds of experiments that I do whenever I get um, whenever I work with a new API. People say, "Oh, can you find me some? Can you test this API for me?" So if I create a new student here, it creates a new student, assigns a unique ID into the system. This is what we call, oops, no, close, escape. I don't want, shut up, postbot. Escape, close, go, whatever. This is my happy path. So I can see, well, oh, it creates a new student in this system. The next thing I want to say, well, what happens if I do something like scripts, something like this. This is potentially malicious code. And in this case, it's not super malicious, but it's a little piece of JavaScript. Um, Basically, what I want is that my system does not accept this. It should reject this kind of input. And why should it reject this kind of input? Because if this ends up in a database and then at some point is requested through a graphical user interface in a browser, this might be JavaScript that is executed in a browser, which might then send all my cookies and local storage details and whatever kind of interesting information is stored in your browser to someone somewhere. So if I see my API simply accepting this kind of input, I know that is a potential security issue. In this case, it is the value of a request body, a request payload. I could do the exact same thing with a query parameter. So what we saw in the previous example. So user name is, and then my script, or this could also be a little piece of SQL code. So let me see if I can very quickly pull up this one, the mandatory XKCD about uh, SQL injection. So this is also an example of input that I want to reject. Sure, I want to accept valid input, but I want my API to also reject potentially harmful input. And JavaScript injection, so the example that we are seeing right here is an example of that. Uh, SQL injection is another example of that. And in fact, there is a whole list here, which is called the big list of naughty strings. Let me zoom in a little bit here and show you the raw representation of this. This is just a public repository with a lot of potentially tricky and potentially even harmful kinds of values, including, for example, emojis, weird kinds of characters, but also if we scroll down a little, just some examples of potentially malicious JavaScript and potentially, where is it further down? Potentially malicious SQL strings. And so strings which can cause SQL injection if inputs are not sanitized. So we would typically do these kinds of validations in a form on a website. And so see if it accepts valid input, but also rejects potentially harmful invalid input. We can and we should do the exact same kinds of tests with our APIs just to see if the APIs properly sanitize this, properly filter out this kind of potentially harmful input. That is called what I showed you just now is called injection. That could be JavaScript injection, could be SQL injection, could be server command injection. Uh, there's different variations on that. Injection is, and oh, I showed you the big list of naughty strings. And injection is a very common kind of vulnerability. This is just a quick example of eBay. So it is a couple of years ago, but eBay had a severe cross-site scripting, a JavaScript injection vulnerability, where their website, which is again just an HTTP call, just like an API is, with a parameter that wasn't validated. So, which allowed attackers to inject malicious code, in this JavaScript code, into a page, which enabled them to get full access to eBay seller accounts, which is something you definitely don't want. So these are very, very things like this happen all of the time. And even still in 2025, these kinds of vulnerabilities still happen. This is how hackers get access to your systems by simple things like JavaScript and SQL injection. Injection is part of you might have heard of OWASP, the Open Web Application Security Project. They keep lists of common vulnerabilities. So injection is I think number 3 on their general vulnerability, top 10 vulnerability list. Since 2019, they're also maintaining a security top 10 list specific to APIs. And in the remainder of this demo, I want to show you some of those vulnerabilities and how you can test for them. So injection, the thing that is very relevant to APIs, but it's not on this list because it's on the general OWASP top 10, security top 10 list. But the remainder of this talk is going to showcasing you some vulnerabilities and how to test for them that are more specific to APIs. First example that I want to give you is the most common API security vulnerability, and that is APIs that expose access to data that people shouldn't have access to. So let me give you another example here that is, there we go. Let me go to authorization. So I'm Susie. I don't look like a Susie, but I'm Susie. So I've got Susie's token, and Susie has an account with the bank with an account number 543. So if they retrieve that data, they see, well, Susie, it's a checking account and their balance 1,500 some things, Smurfs, dollars, pounds, whatever. So this is valid. So Susie can see data for their own account. And 542, and so because 543 is their account, they say, well, maybe there's also an account with an ID 542, but they don't have access to that. Now, this means, so this is a good practice for public API security-wise. Just tell them it doesn't exist. Whether the account number 542 actually doesn't exist, or whether it does exist, but Susie just hasn't access to it, doesn't really matter. The response is 404. And that gives Susie and also hackers the least amount of information because I don't know if this account does even exist. But that experiment that I just did, I can of course repeat that quite easily with Postman for a range of accounts. So let me go to the collection runner here and only execute this one and select a CSV file here with a list of potentially existing valid account numbers. So what I expect here, I also didn't explicitly show you that I added an assertion to this test that checks that the status code is 404. So I've got 100 account numbers and I expect 99 of those tests to pass because Susie only has a single account with this bank, account number 543. So I expect all tests to return a 404, except the one for account number 543, which returns a 200 because that is Susie's own account. So if we run this test, I can see it fails once and it fails twice. And I can see if I select only the failed cases that yes, this is what I expected. So I expected this to return a 200 because this is Susie's own account. But what I didn't expect is this one. But if I close this one and go back and remember again, I'm Susie, I'm authenticated as Susie, but it turns out I can also see data for Andrew. Susie has no idea who Andrew is, but they can see Andrew has a savings account with this bank with a balance of nearly 100,000 Smurfs or dollars, which is potentially very interesting to Susie and also to hackers. So again, this is a very simple experiment. And just do a request for a range of potentially valid IDs and see if there's data that I can access that I should not be able to access based on who I am, based on how I authenticate. And this is an example of what OWASP calls broken object level authorization, or BOLA. And as you can see on the 2023 OWASP API Security Top 10 list, which is the most recent list, because they don't release one every single year, it is the #1 security vulnerability. This is the kind of vulnerability that happens most often in the real world. It is the most popular is probably not the right word. It is the most common, the most frequently occurring kind of security vulnerability. And it's really easy, really straightforward to test for, as you can see. Because if we have resource IDs, in this case account IDs, that are easy to predict or easy to find. And so if I can predict valid resource IDs, for example, the account numbers here, if I've got an account number 543, there's probably also an account number 542 and 541 and so on, 544. Or if I can easily find a list of valid resource IDs, I can easily iterate over that list. And in this case, for this example, it was only 100 account numbers, but that could also be thousands or tens of thousands of these account numbers. So that is something to look out for. Another thing that we could see in this specific example, is that there's either an interface or in this case a total lack of rate limiting. Rate limiting is the amount of requests that a specific client can make to a specific endpoint in a certain amount of time. I want to be able to consume an endpoint, but not make too many requests because I can just send too many requests and then basically DDoS the server, but I can also use it for data scraping, which is what I did just now. That is why rate limiting exists, to limit the rate with which a single endpoint or single computer can make requests to a specific endpoint on a server within a given amount of time. And in fact, this is what OWASP calls unrestricted resource consumption. That is insufficient or a total lack of rate limiting. And that is another entry on that OWASP API Security Top 10 list. In fact, it is number 4 on that list. So that's also something to look out for. Also something that is pretty easy, especially with a common performance testing tool like JMeter or Gatling or Locust or K6 or whatever. This is something that is very easy to test for. Just fire a high amount of requests to a specific endpoint in a short amount of time and see if the rate limiting kicks in. This is an example of how this went wrong in real life. And again, it's a couple of years ago, but this really happened where at the US Postal Service, where anybody with an account at USPS.com could view the account details for at least 60 million other users. And in some cases, they could even modify it. So this is a prime example of broken object level authorization. All of these users could see data for all of these other users and that's data that they shouldn't have access to based on who they are, but they did. So that is, again, the most common kind of API security vulnerability according to the OWASP API Security Top 10 list. And it's something that is relatively straightforward to test for. If we can see that data, maybe we can modify it as well. So that is another example of a vulnerability. So I've got you another example for that. So this is a file. I retrieve data for a file. So I should be able to see this. I should have access to a system. I can see, well, what fines do I still have to pay? So in this case, there's a fine I have to pay 180 somethings again. I don't like paying fines, so maybe there's a way to get rid of it. So maybe there's a way I can modify the data in the system other than by actually paying the fine. So maybe I can delete it. Okay, that is not allowed. That is good news, at least from an API security perspective. Maybe I can just overwrite the data with nothing. That is also not allowed. But maybe I can set the amount to 0 with a put. That is also not allowed. Or with a patch. Oh, that is interesting. So apparently something happened here after I patched this data, because when I try and retrieve it now, my fine is completely gone, which means it has been paid for without me actually paying for the data. Again, this is another kind of vulnerability. So broken object level authorization is about seeing data that you're not supposed to see based on who you are. This is an example of broken function level authorization, which is the ability to perform actions on data other than just seeing it, modifying data that you shouldn't be able to modify based on who you are. So just having the rights to modify or even delete data where that data is read access only, for example. And that too is a pretty common security vulnerability because it's number 5 on this list. So another example is that if as a regular user I have access to specific kinds of admin endpoints, that's a different example of broken function level authorization. So related is maybe not the best word in retrospect, but where I see so if I can see data that I should be able to see, there's a good probability that I can also that there's other things that I can do with the data too, because both of them are caused by broken, incorrect, or incomplete, or just non-existent role-based access control on that data. And so I have permissions on the data that I shouldn't have. So if I see data that I shouldn't be allowed to see, maybe I can also modify that data. So I should definitely also test for that. So if you happen upon seeing data that you shouldn't be allowed to see, it's probably a good idea to also check, well, is there anything else I can do with that data that I shouldn't be allowed to see? Maybe I can also modify it. So it might be a good idea to check for broken function level authorization too. This is an example of broken function level authorization in action. People who just traded, used some of their own Bitcoins to sell Bitcoin that they didn't own. And that is not a UI, it was not a UI bug. It is on the ledger, so it is on the live order book. So this was a pretty big broken function level authorization natured leak at Coinbase, one of the largest Bitcoin platforms in the world. So this was a pretty big deal, which you can also see by the bug bounty that was paid out, $250,000. That's a decent payday. So these kinds of vulnerabilities definitely happen. So I see I've got some more examples. Let me show you this one. Yes, James, thank you for that. James says in the chat, it's probably worth mentioning that you should always get permission to perform this sort of testing. That is absolutely 100% true. Please don't just try and hack publicly available APIs. People sometimes they appreciate it. Oftentimes they don't. And especially if you do it, please don't just brag on it on LinkedIn afterward, or brag about it on LinkedIn afterwards. So be very, very, very careful with that. If possible, absolutely get that permission. if you stumble upon something that you didn't get permission, that you just stumbled on, because that sort of kind of stuff happens, uh, please be a good person and actually report it to the people of the company who concerned, and not just put that out there in the open for other people to abuse it. That's not really the decent thing to do. So thank you for pointing that out, James. I appreciate it. Um, Next example is an API for game shop where I can order this. Yeah, shut up. So I can FIFA 24, pretty common, pretty uh, basic run-of-the-mill kind of game. So I can order one and that is accepted, and I could order 15 copies if I wanted to. I don't know what I wanted to do with 15 copies of FIFA 24, but the game shop doesn't really mind. Um, However, you've seen that with most shops. They sometimes have articles that they have limited stock, and maybe specific unique kinds of items that is strictly one copy per person, one copy per customer, for example. That's true for this game shop as well. They've got a game called Gamma Attack, and people can order the Gamma Attack. By the way, for those of you who don't know, you probably don't because it's super obscure, but it's the world's rarest video game. So customers can order a single copy of Gamma Attack. That's all well and good. But if they try and order multiple copies, they get an error. Awesome. So this is all good. The problem is, um, what this game shop, the people who implemented this API for this game shop didn't think to cover is a different kind of scenario where, because again, they wanted to make absolutely sure that it's one copy per customer only. So they covered this scenario, but what they didn't cover is the scenario where one customer just placed multiple orders, potentially many orders, all for a single copy of Gamma Attack. This isn't necessarily API or API data security related, but this is a way where people can misuse a system through the API. This is another type of vulnerability. OWASP calls this unrestricted access to sensitive business flows, or UASBF for short, because who doesn't like stupid acronyms? But yeah, this is called unrestricted access to sensitive business flows, and it's basically um, avoiding, abusing business logic, business rules of a system through an API. So how do we prevent these kinds of vulnerabilities to happen? For example, I'm pretty sure that if a tester would have been involved in the design of this API and the system behind it from the start, that they would have thought of this scenario. And so at least someone who doesn't just think, how can we make this work? But also thinks about all the different ways in which things might not work. Testing. So this is just one example where having testing involved very early on in the process could help you improve the security of your APIs. So I have discussions about what are our sensitive business flows? How would people be able to use those and abuse those? And then implement the prevention measure and take prevention measures, implement rate limiting, implement proper role-based access control, implement filters. Um, the example that I just gave you, a real world uh, uh, um, alternative to this is like if tickets to concerts go on sale, and you want people to be able to order 2 or 4 tickets, but not 4,000 and then just sell them on the black market for 2 or 3 times the price. So you probably want to take some prevention mechanisms to that. And these are just a couple of examples. I like using CAPTCHAs, biometric solutions, or just implement a mechanism that detects non-human patterns. For example, if there's only a couple of milliseconds between a user putting something into a shopping cart and proceeding to the checkout, it's probably a bot. So block that kind of behavior. Is that 100% foolproof? No, it isn't. Um, is that a measure that improves the or decreases the chance of people abusing your system? Absolutely. This is called in security, people talk about the Swiss cheese model, where every security measure that you add to your system in itself is not enough to guarantee that your system is secure. But if you put enough of these security measures in place, the risk that an attacker is able to bypass all of these individual security measures becomes smaller and smaller to the point where um, the risk level is acceptable. And so this is typically true for every security measure. So no security measure other than a completely disconnected system, but well, then it's unusable. Um, None of these security measures in and of themselves are um, guaranteeing 100% secure systems. But if you have enough of these security measures in place, that would bring down the risk to an acceptable level, typically. And that is so one way to reason about it, to think about this is by means of slices of Swiss cheese. Just because of the time, I'm going to skip the other ones. So there's a couple of many, or at least quite a few potential security issues that we covered today. There's a couple of them that we missed. So what I did cover is broken object level authorization. I did not cover broken authentication. That's the one that we skipped. I also skipped number 9. Those two were in that last example that I just skipped. But we also covered unrestricted resource consumption, which again is the lack of rate limiting. Broken function level authorization, which is the ability to modify data that you shouldn't be able to modify based on who you are. And that last example was again unrestricted access to sensitive business flows. Um, Broken object property level authorization is very similar to broken object level authorization, but it deals with individual fields in a resource instead of the entire resource. Server-side request forgery is the ability to learn about or get access to a server through the URLs that it accepts. A security misconfiguration is basically it's like an umbrella vulnerability for lots of different kinds of things that you can misconfigure around the security of your system. And number 10 is so numbers 1 through 9 are vulnerabilities that should be fixed on the provider side, so on the server side. Number 10 is the only one that should be that it deals with the consumer side. And so if you don't properly um, validate and what's the word I'm looking for? Sanitize. That's the word I'm looking for. Sanitize the data that is being returned by an API. You as a consumer could be in trouble too, because that API could also send potentially malicious data to you. And if you don't do that, then you're vulnerable to security vulnerability number 10 on this list, which is unsafe consumption of APIs. I'm going to also skip this. So that wraps up the practical part of this talk and the demo. I hope that this gave you an example of some inspiration of how to get started with API security testing yourself. I hope that these examples showed you that it doesn't have to be super complex or super specific, but that that you can uncover a lot of valuable information about the security of your APIs and the data that, especially the data that's exposed by those APIs, with just a bit of creativity, curiosity, and common sense, and a common API testing tool. Again, I used Postman. That could be Bruno. That could be Karate. That could be Rest Assured. It doesn't really matter which tool you use, but you can do a lot of very valuable API security testing with uh, your brain as a tool and just a common API test and a common HTTP client, again, like Postman or Bruno or whatever. If you would like to learn a little bit more about API security, this is a resource that I can highly recommend. API Sec University. Let me show you the API Sec University. There we go. This is a platform that contains a lot of API security testing courses, API security related courses, and some of them are um, specific to testing. Some of them are, for example, specific to connected cars and fleets. All of these are absolutely free, and I've completed these two. So this is basically their API Security 101 course, and this one dives a little deeper into the OWASP top 10. Um, I haven't seen much of the other courses, but if they're of the same quality, and I have no reason to expect they aren't, this is a super, super valuable learning resource if you want to dive a little deeper into API security and API security testing. Again, all of it is completely free, and people like free stuff. So this is a resource that I'm more than happy to recommend to others. And that's it from my end. Before we move into the Q&A, I see we've got about 10 minutes left for that. Um, if there's anything that you want to know, want to share, feedback, questions, whatever, by all means, um, hit me up on LinkedIn, send me an email, and I'm more than happy to continue the conversation. Also, as Vishanka said, this meeting is recorded. It will be published on, I think, at least on YouTube, and also through LinkedIn, probably. So you can always rewatch it later. And yeah, that's it. Let me go back to Q&A.
Yes, boss. It will be published on LinkedIn, YouTube, and our website. And separately, I'll send you the link. Then you also can share with the others. It was a great
Awesome.
session, boss. Yes, and you can ask questions if you have any.
I see a couple of things come up in the chat.
Yeah, yeah.
Thank you. This is all. Thank you. Ooh, Kingsley, you've got some questions. Um, so let me do those. Do first one. Do all security related issues originate from bad development practices, or can they also arise from company-wide processes and business logic? Um, so one drives the other, really. So definitely they can come from both. So if a company simply isn't aware of security related risk, or if their development process doesn't allow for thinking about talking about potential security issues, or if they don't have the required expertise, just simply that no one is really has the experience of um, identifying potential risks, and then that is definitely uh, a source of security issues. Sure, everything goes through development, and development teams have responsibilities. And that's not just the developers themselves, that the testers, that designers, that's everybody. But I think it's a little bit harsh to just put all the blame on them, because a lot of the time, the fact that they're not aware of security and potential security risks um, is not just uh, their fault. It is simply it might definitely also be the fact that the company just isn't really aware of it, doesn't see the risk, is yeah, or just hasn't built security awareness into the whole culture enough. So it's definitely something that can arise. And sure, sometimes it's just people are bad development practices. Sure, that could be a source of potential security issues too. But it doesn't necessarily have to be. Second question is, can QA teams play a role in adding security to CI/CD and agile processes, or should that be left entirely to cybersecurity specialists? Um, I think they can, and I think they should. That is our responsibility too. First of all, I'm going to just leave aside the fact that I don't really believe in QA teams, so let me substitute that with development teams. The answer doesn't really change, by the way, but yes, I think just like um, testing for functional correctness, like we do with a lot of our unit and integration and end-to-end or whatever kinds of tests, um, we should be adding these kinds of. So the tests that I did are pretty exploratory in nature, and that's a good start. But some of them, most of them, maybe even all of them, um, could be then automated and made part of a build pipeline too. So you get that kind of feedback every time you create a new build. Because it might be too expensive and too time consuming to do that manually each and every time, just like we do with what we call functional testing. So yeah, we can and we should think about and discuss, well, is this information, this security related information that we've got, is it important enough for us to know every time we create a new build? And if so, we should definitely make this part of a build pipeline. So yeah, that is definitely something that we should discuss. Um, all right. I think that is the questions for now. Any other ones? Things that I've missed? If not, Vishanka, it's over to you. But
Yes,
yeah,
regarding
I
to
think we
question
can wrap
two,
this up then.
and I also have the same question regarding to second question. Then Kingsley has mentioned was because under non-functional testing we are conducting security testing, and it is doing by the another team. So normally manual and automation engineers are not involved in the security testing. So if we also can get the some sort of responsibility of this API security testing, I think it's better, right?
It is, yes. And that is it's also why I have a problem with that classification of functional and non-functional testing, because I
Mm.
see this happen all the time. It is that teams, and that's developers and testers and everybody in development teams, we focus at, so if we classify things as functional, non-functional, we tend to put a lot of emphasis on the functional part. We want to make things work,
Mm.
and we spend less time thinking
One.
about testing for security and performance and usability and accessibility and all those and reliability, those kinds of things. So, but it is just as, if not more important. So, yeah, absolutely.
Yeah. The other question I had about, so it was already discussed, and I wanted to know what are the resources you would like to recommend. Then you have mentioned a couple of sites.
Yeah, so I think API Security, API Sec University is great.
Mm.
Also, OWASP themselves. So if you go to owasp.org, there's lots of useful information on that side as well.
Okay, so regarding the OWASP guidelines you have mentioned was, so as functional test engineers, up to what extent we can go with these guidelines? So at least if we are aware, if we have some kind of awareness of these guidelines, then we can do some sort of testing before handing over to the security testing team, right?
Yes, exactly. So I think at this, I tend to use this as you said, as a guideline. This gives me ideas of things to look out for.
Mm.
Um, some of them are easier to test than others. And as you said, it's probably still a good idea to have an expert do a deep and thorough security test or scan or penetration test
Mm.
every now and then. But there's a lot of low-hanging fruit that you can, a lot of things that you can test for yourself very easily. Um, and then just find and report and fix much earlier. And you don't have to wait for that penetration test that typically only happens once every 6 months or so.
We can do it at the early stage if we get that part. Yes, true. And regarding out of
Exactly.
the yes, out of 10, so as functional test engineers, what needs to be prioritized from our end?
From this list, you mean?
Yeah.
I would say, well, just start with this one. Start
Mm.
at the top because it's the most common one, and it's also the one with the highest impact because this base again, this means broken object level authorization is people who have access to data, who can see data that they should not be able to access based on who they are. First, that is, first of all, it's the most common one, and it's also one with a lot of impact. So
Mm.
I should start just see, well, oh, um, if I authenticate as user John or user Susan, can I see the data that is associated with John or Susan? That's fine. But can I also not see the data that is not associated with John or Susan?
Mm.
So that's a great start. And that is some people might think of that, but that is a security test because I'm testing a security property of my system.
And role-based access is something that we can check as the next, right? So,
Oh yeah, no, absolutely. That is something that you can start checking right after this meeting. Not for you, Vishanka, because it's your evening, but no, that's something that you can pick up right away. Just say, well, oh, I can confirm that I can see the data that I'm allowed to see, but can I also not see the data that I shouldn't be able to see? That's a great start.
yeah. Uh, I don't have any
I
more questions, boss.
I
So if anybody
I
has,
think we're also um pretty much out of time. So that is excellent timing.
yeah, excellent timing. Yes. And
So
so if we don't have any questions, we can wrap up, I think. And right,
yep, absolutely.
don't go, don't leave. Thank you so much, boss, for bringing up these valuable information and sharing with the community. It was really helpful, and I think for all journeys, I think it was a helpful session and was brought more valuable insights. Basically, the risk he has as mentioned, associated risk he has mentioned is very important because now we know API security testing is cannot be considered as an optional thing. It is a essential thing. And this session helps and encourage us to also go deeper into this topic. And yes, thank you so much, Bas, and for all joining. Thank you so much for your interest and participation. And so Bas mentioned his contact details. So if you have any question or query, then you can contact him, contact us. And yes, we can see you all in next webinar. Thank you so much.
Thank you so much, everybody. And of course, to you too, Vishanka, for hosting us.
Yes, thank you so much for accepting our invitation and your time, Bas.
You're welcome.
Okay, then have a great day, all.
Have a great day. Thank you so much. Bye bye.
Bye bye.